This endpoint takes more than 60 seconds just to complete. Let's make it under 1 second. This is the endpoint that we have. This is a bad example, by the way, because why I'm gonna show you is a bad first, then we're gonna walk you through how can we improve our response time, starting from the worst case scenario. Then we're gonna be trying to improve by making more SQL optimizations. Then we're gonna make indices. Then we're gonna make multi-threading, and eventually we're gonna make caching mechanism. We will reduce the time from 60 seconds to less than 1 second, and I'm gonna show you how in this video. So here we're loading the dashboard, and basically our dashboard is just orders. That's basically what we do. So if you notice, this is a method that has all the necessary data that we use. It takes some kind of total amount or the total number of orders basically, and we have so many statuses here. So like created, confirmed, completed, and if you have noticed, all of them uses the same method. One way to think about this, you don't really need to go to the database every single time. What we need to do is to combine all this kind of common part and make it just one time. Go to the database, get whatever you want one time, instead of just going so many round trips to the database, getting some kind of data that you can have taken just by going one time. This is one way to optimize, and this is what we're going to be doing. Also, we have a couple of other methods that we use just to make some more queries which are related to the count states. Also, in the SQL statements that we use, currently as of now, we're using a materialized view, and we're using the inner SQL, which isn't really optimal, but sometimes it's necessary. So in our case here, is it really necessary? What we want here, that we're making inner query, we're ordered by creating at. This means we're sorting everything within this table, everything. And then we're gonna store it in materialized view called sort all. And after sorting this, you're gonna selecting the account based on a condition. Do you really want all this kind of stuff? I don't really think so. What you need to do is to make this query with a filtration query first. You need the workflows to happen. The first thing you want. You don't really want to sort everything that you have. This is one way of doing things bad. And let's take 1 second to test it out and see how long does it take. I'm gonna be opening my Docker Compose here. So by the way, this is Docker Compose, and now I'm gonna be running my application. Also, for the sake of this example, I have made a seed controller. This seed controller will be generating for us 2 million records in our database for us to test this kind of behavior and see how impactful it is. So I'm gonna now be seeding 2 million records here, and it's gonna be taking some time. So bear with me. Okay, so now it completed the seed right now. Let's get the account and see if it's gonna be working fine. Okay, so we have 2 million records in our database now. Let's jump into action and see how long it's gonna be take to make our query here. It's also gonna be taking some time, so bear with me. Okay, so it took like 1 minute 32 seconds, which is really bad. So we need now to improve what's happening here. So like I said, we had seen that it takes like way too kind of round trips into the database. So I have each of those branches is one improvement. So one is using a less round trip. So basically you don't really need to go to the database as many as you're expecting. So I'm gonna be showing you the differences here. So what happened, instead of going to all this kind of amount of round trips, what we do is just basically, hey, you're going to be aggregating just one time. This aggregation takes all whatever you want in one single time. This is a whole different improvement here. And instead of using, hey, you're using materialized view, we're not going to be using materialized view. Why? Because it's pointless in our case. You don't really need also to sort at first. What you're going to need, you need the filtration that's going to be happening, and that's basically it. You don't need the sort, you don't need anything. So that's basically what we're going to be doing, and let's see how improvement had happened just by changing this kind of ordering and this kind of behavior. And instead of going to the database so many times, you just go a little bit of like, what's that? The total was like 4 times. This time was only going to the database 4 times. And let's see this kind of improvement. Previously was taking 1 minute 32 seconds, and now it takes 790 milliseconds, which is really nice, but there is also a better area. Let's run it a couple of times to see kind of ranges, like this is 565, so and another one's 500. This is really low, but we also need to be even better. So let me show you an even better approach. I have noticed, by the way, we're using some kind of statuses here. We have 7 different statuses, and we're using created as. So one way, a really good way in order to optimize when we have many data, many different data is using indices. But since unfortunately status here is kind of hard-coded 7 values here, so our index basically will have 7 branches to split the database at, which is the 7 statuses that we have. So you might be wondering, if we introduce index here, would it really help us here? Let me say it might help, it might not, depending on how the dataset was split at. But I believe it's gonna be helpful regardless on the long run. So basically, if you have like 100 million records in your database and you wanted to split it, I believe it's gonna be beneficial to split it. Why? Because instead of sequentially scanning through like 100 million records, you're gonna be splitting it across the different statuses that we have, and you will have like whatever status that you want. So if, for example, the confirmed was 100K, you're gonna be searching within this confirmed, which is 100K. That was just an example. And in addition to our indices here, we have a range index. So we can also use the created at in our index. So I believe also it's gonna be beneficial. So having index here isn't really bad. It's gonna be taking some kind of storage, I believe. So yeah, but it's not really bad. I feel like it's gonna be beneficial in our case here. So maybe I'm wrong. Let's try it out. Okay, so I have decided to create a couple of indices here. I have used the leftmost equality, then range. So we're using equality on the first left column, and then we're using the range. This is what I'm talking about. So the status on the left side, the range which is created at on the right side. This is also one rule in Postgres and in many other databases, such as, for example, Mongo. It uses like the equalities and range, and then something else that I can't remember now. Those are the indices that I have used, and let's rerun our application and see how it's gonna be affecting the response. Previously, it was taking like 500 milliseconds. After the indices, we're gonna check it out. Okay, so now the indices are created. Now let's rerun. It was taking like 500 milliseconds. So now we're gonna run it, I think, again. And after running it, it is now 951. Let's run it one more time. 800 milliseconds. So we believe it's kind of similar time. Now it's like 680. It's kind of similar. It didn't really make any impact. So now we need to understand what happened. So I had made this explain analyze because I want to understand what on earth is happening. So let's take this, for example, like core aggregate. So what happens here? This is the execution time. It took like 106 to calculate the aggregation method that we had used. So let's see, does it really use index or not? This is the index conditions that was used. There was index search, and the index search was using the created at. So basically, it took this index and made the index condition more than this range and less than this range. So it had used the created at in our index here. And after taking it, what happened else? It's gonna made a parallel bitmap heap scan. So after this index, it made a sequential scan on the heap results in order to find what we want to search, and this execution time took like 106 milliseconds. So in our case, the index wasn't really impactful. So what else can we do in order to improve our dashboard here? Here in our optimized order here, these are the queries that we have now as we're using indices. And if you notice, I have a question here. Does all of them depend on each other or not? The answer would be no. You don't really depend on each other. So this can run on its own, this one can run on its own, this one also can run on its own. Since we have this option, why don't we think of multi-threading? Why not we just try multi-threading? Each thread does this kind of execution on its own. And this is what I'm going to be introducing next. I have defined a thread pool here, and this thread pool consists of 4 cores that are the normal cores, and the maximum number of cores that we can have is 8. And this is the queue capacity of mine, which is 200, and some kind of themes that's gonna be helpful when you're checking this kind of in log, but it doesn't really matter. So now let's get into our code here. So previously we were using single thread, which is the main thread. Now we're going to be using completable feature, and this async uses our dashboard query executor, which is the executor that we have created here. So now what I'm going to be doing, after running each one of them in its own thread, I'm going to be joining them here, and after joining them, I'm going to be using the result set that come from this completable feature, which basically means each one of those queries run on its own separate thread, and we're going to be taking the results, and let's see, does it really help us or not. Okay, so application has started. Let's rerun. Previously it was taking like what, 600 to 900 milliseconds. Now let's see how long does it take. It took now 1.11 seconds. This is more than before, but now it's going to be 230. Okay, so basically maybe for the first one it took like more than expected, but the later time it is now 250, 300. So it takes a very little, like less than 400 milliseconds. This is amazing. So We have done really good improvement, but do you think that's enough? The dashboard doesn't change every single minute, doesn't change every single second. Dashboard is something that is a dashboard, so you can update it like every couple of periods. This gives me like, why not we use cache? We just cache the result one time, and every time we go to this API, we get the result from cache. This means we're gonna be saving up so many time. Let's try this out. I'm gonna be using caffeine cache, and this is the configuration that we have. We're just gonna be expire after 300 seconds, well, I believe 5 minutes or something like this. And this is what we're gonna be. We enable the cache here, and in our service here, we're gonna be caching it through this our way. We're gonna be caching from and to. This is how we're gonna be caching it, because sometimes different users have different kind of values from and to, which is depending on the kind of type of dashboard that they are searching for, and we're going to be caching this kind of result. Let's rerun this project using our cache and see how long does it take. Previously it was taking like 264, around 300, maybe like less than 400. Let's rerun it and see how it's going to be impacted. The first request is not cacheable, but since we're going to be using single source of truth, which is our cache, it should be the first request is going to be taking like this kind of range, but the next and third and more and as many requests as you want after the first one should be less than the first one. So let's rerun this one and see, hopefully it will gonna be working. Okay, so first one is gonna took 840 milliseconds, which is a lot. I'm not gonna mean a lot. This is a lot. So let's rerun again. It's 327. So it took the similar time as before. So the cache isn't really making any sense here. I believe it doesn't really make sense because we're not adding any kind of custom period. So every time we're making the instance of now, and since we're making instance of now, this means this is a timestamp. Like we're not really hitting the cache here. So in order to hit the cache, we'll need to have some kind of specific value, and this is what we're gonna be trying to do. So let's try this one. We'll find out it took like 600 milliseconds. Now let's rerun again. 7 milliseconds. That's the cache that I'm talking about. This is the importance of the cache. So we have moved from a whole 1 minute 30 seconds to 7 milliseconds, to 5 milliseconds, to 7 milliseconds. This is what I'm talking about when we're talking about optimization. From a whole minute 30 seconds to just less than 10 milliseconds. And this is what kind of differentiate between a person who knows what on earth he's doing and a person just trying weird stuff. So hopefully you enjoyed this kind of content, and if you're interested into learning more anything about optimization, database, operating system design, whatever you want, feel free to comment out. I'm gonna be making a video about it. See you next time. Bye bye.